record. Will take a check.
Good morning, sir.
Good morning.
Morning, sir.
Morning. Last class we have discussed the overlap add method. Do you have any doubt? Overlap add method?
No, sir.
No doubt. Everything all right? Okay, if everything all right, then this class I will take one more example. Some people was asking yesterday that you give one example with odd number of data. So odd number of data points, I will give one example. Okay.
Sir? বলছি যে ওই একটা অ্যাসাইনমেন্টে কোশ্চেন দিয়েছিলেন নাম্বার অফ ওভারল্যাপ, ওটা 8 এর ক্ষেত্রে 3 তো হবে, মানে ওভারল্যাপটা তো 3।
Okay, so now we'll discuss the another example in which you are having odd number of data. Okay, now if I have odd number of data, suppose this is the example. This example I will not write like I have explained previous example, because you already know these things. Therefore, what we will discuss today just hints, but the thing is that you have to write in the exam, you have to write as per I have solved yesterday. But this example I have not solved entirely, only I have solved, I didn't write anything, only I have given the solution. But
স্যার ওই ল্যাঙ্গুয়েজটা পুরোটা লিখতে হবে?
ল্যাঙ্গুয়েজটা পুরোটা লিখতে হবে মানে while solving the problem, whatever I have written, you have to write everything. Okay, previous problem like I have solved, this thing is not required, this portion direct calculation is not required, like what you write the combined output of the convolution of each section, like this one, yn will start at start end at like that you have to write. Means this is the start of the solution problem and this is the solution, like that what we have written previous problem you have to write like that. Okay, this problem I have not written that detail, only thing I have written solution part, so writing will be as per previous problem. Okay, now in this problem we are having odd number of data, like suppose say 1 2 3 minus 1 minus 2 minus 3 4 5 6, these are the 9 data points in the Excel, and hn you are having 3 data points, 2 1 minus 1. Now the question is hn having 3 data, all right, 3 samples 0 to 2, 9 samples 0 to 8, or 9 data 0 to 8. So now what I have said, while the longer sequence, this is the longer sequence, you have to divide the longer sequence into smaller sequence. and that length may not be equal to hn or may be equal to hn. What is your n3? So that may be equal to hn or may not be equal to hn, but when I solve any problem, I always take the smaller length is equal to hn. That is also not a problem, but you can take different length as well. But I always follow a same procedure, so I always take same length. Now, if you look at hn, length is 3. Length of hn is 3. Everybody agree with that? Length of hn is 3.
Yes.
Okay. Now, length of xn is 9. So I am dividing this sequence into 3 sections. One section consists of x1 of n 1 2 3, n equal to 0 1 2. Another section x2 of n minus 1 minus 2 minus 3 minus 1 minus 2 minus 3 4 5. Another section is 4 5 6, that is equal to n equal to 6 7 8. Agreed? That's why I have taken this sequence. Now what I did here what I have taken this length as I explained in this theory. In this theory, what I said, n1 is the length of the longer sequence, n2 is the length of the smaller sequence, and this is n3 samples, sequence to be divided. That n3 may be equal to n2. So I always take this n3 equal to n2, not an issue. Okay. Now, here your n3 equal to n2. So now here n3 equal to n2 equal to 3 in the example today I am discussing. Agreed? Agreed? Now, in this, if your length of hn, this is your n2, this is how much? In this theory, if you see, here, then number of overlap has to be n2 minus 1. So in this example, how many overlaps should be?
2.
So number of overlap has to be 2. Okay. So number of overlap has to be 2. So that I have to understand before solving the problem. Now, if I look at the solution further, then this is my extent. Now, how to find y1 of n? y1 of n will be x1 of n convolution with hn. y2n will be convolution of x2n with hn. And y3n will be convolution of xn. The y3n will be convolution of xn and hn, x3 of n and hn. Now, here I have written x1 of n. Here it is x2 of n. This is x3 of n. And I have written hn here. Now, if you multiply 2, 4, 6, then 1 if you multiply 1, 2, 3, minus 1, it will be minus 1. Similarly, if you multiply 2 with minus 1, it is minus 2, minus 4, this is minus 6. And 1 is multiplied with minus 1, this is minus 1, this is minus 2, this is minus 6. Now, if you write this 2 into 4, this is 8, 10, 12, 2, 4, 5, that is 4, 5, 6. 4, 5, 6 is your x3 of n. Now, x3 of n, if you multiply 2, 2 into 4, 8, 10, and 12. Then if you multiply with 1, this will be 4, 5, 6. If you multiply with minus 1, that is minus 4, minus 5, minus 6. Now, if you want to write y1 of n equal to 2, 5, then this will be 7, this will be 1, this is minus 3. Now, y2n again minus 2, then minus 5, then this is minus 7, so 6 minus 2 minus 8 plus 1 minus 7, then it is minus 1, then it is 3, minus 1 comma 3. Now here it is 8, this is your 40, this is your 12 plus 5 minus 4, that is 13, 6 minus 5 1, this is minus 6. This will be your y1n, this is y2n, this is y3 of n. All right, up to this is all right. So what we did, the longer sequence having length, longer sequence length kitna? How much? 9. 9? Longer time. Smaller sequence length 3. So I have divided into three sections, x1 of n, x2 of n, x3 of n, each having three samples. Now I am convoluting Hn with each section x1, x2, and x3. I mean x1 of n, x2 of n, x3 of n. Then what I have obtained? I have obtained y1 of n, y2 of n, and y3 of n. Now, what will be the limit of y1 of n? Limit of y1 of n will be 0 to 0 to
0 to 5.
4 na 4
0 to 4 and 5 element.
हाँ तो हमें
5
0 to
element, 0 to 4.
0 to 4, right?
Hmm.
So the 0 to 4 I said, you said, so like 2, 5, 7, 1, minus 3. This is 0 to 4, I have written. Y2 and what will be the limit? Limit will be 3 plus 3. Limit will be y2 of n
0 to 4. 3 to 7.
3 to 7. Everybody agrees with that?
Yes.
No, others. Limit of y2 and n. Lower limit will be 3 plus 0. This is 3, na? This is 3. 3 plus 0 is 3. And 2 plus 5 is 7. So this will be 3 to 7. Agreed? So this will be 3 to 7. 3 to 7 means again I will write minus 2, minus 5, minus 7, minus 1, and 3. This will be 3 to 7. Now let us look at y3 of n. Y3 n, what will be the limit? This is 6 and this is 8.
6 to 10.
6 to 10. Agreed? Everybody?
Yes, sir.
Fine. So this will be 6 to 10. If this is 6 to 10, then you see this is 6, 7, 8, 9, 10. 6 to 10. Now see where are the overlaps? The overlaps are here. So 2 plus minus 2 plus 1, this is minus 1. Minus 5, minus 3, this is minus 8. If we add this overlap. Then if you look at the overlap here, 8, 1, that is 7. Then 14, 13 is 17, 13, 1, minus. And if we look at y of n will be 0 to 10. 0 to 10, this is 0 and this is 10. Now let us look at there.
Sir,
Follow.
so you said number of overlaps বললেন যে n2 minus 1 হবে তো এখানে তো
n2 কত?
Into the 3. 3 minus
তাহলে তো এখানে number of overlaps তো 4 হচ্ছে
কেন?
1.
n2 টা কত? n2 টা হচ্ছে তো n2 হচ্ছে length of hn.
হ্যাঁ।
The length of hn টা কত? Length of hn হচ্ছে 3.
3. হ্যাঁ।
Number of data points is the length. So if you have 3 data points, the length is 3. So if it is 3, then n2 is 3. 3 minus 1 is 2.
বাট এখানে যে
ওসে টোটাল লেন্থ টোটাল ওভারল্যাপটা 4 হচ্ছে না ওটার সঙ্গে এটা বলি
Total overlap?
টোটাল ওভারল্যাপটা 4 হচ্ছে না ওটা ভাবছি ওই এক একটা তো n2 মানে এক একটা সেকশনে
এক একটা সেকশন each সেকশনের ওভারল্যাপটা হবে n2 minus 1.
টোটালটা যেরকম
টোটাল ওভারল্যাপে যতগুলো নাম্বার ওভারল্যাপে 2 টাইমস অফ দ্যাট।
যতগুলো তো
যদি দুটো থাকে 2 টাইমস, যদি n নাম্বার অফ, এটা অবশ্য ডিপেন্ড করছে কিসের উপর, কতগুলো সেকশন আছে তার উপরে। ইফ ইউ হ্যাভ সাপোজ সে m নাম্বার অফ সেকশন m, তাহলে টোটাল ওভারল্যাপ উইল বি m টাইমস n2 minus 1. Right? This was also question asked in the GATE, you know, in one GATE paper it is given that you have m number of blocks and impulse response having length 3. What will be the total number of overlaps? That will be m times n2 minus 1.
সে m টাইমস একটা মাইনাস হবে না, ধরুন এইদিকে দুদিকেরটা তো মানে এন্ডের গুলো
ওভারল্যাপ, নাম্বার অফ ওভারল্যাপস।
হ্যাঁ,
না
এখানে যেমন ধরুন তিনটা সেকশন,
হ্যাঁ তিনটা m minus m -1 times into m minus 1 into n2 minus 1, sorry m minus 1 into n2 minus 1, দুটোতেই minus 1 হবে। ওকে, m minus 1 times n2 minus 1.
n2 minus 1.
Actually in the solution there are 4 answers, you know. One is m times n2 minus 1, m minus 1 times n2 minus 1, m minus 2 times n2 minus 1, m minus 3 times n2 minus 1. Right? So the final answer, what I'm saying, that number of section minus 1 into length of impulse response minus 1. So it will be m minus 1 into n2 minus 1. Yes. Agreed? Everybody understood the solution?
Yes.
Is it okay? Sanjana? I hope it's all right now. Okay.
Yes.
Yes, sir.
Very
Yes,
good.
sir.
Now, what you have got, y1 of n, y2 of n, and this is your y3 of n. Then if you add, this will be your answer. Now, if you perform the linear convolution directly, then what you have to do? Suppose you are having 1, 2, 3, minus 1, minus 2, minus 3, 4, 5, 6. This is HN. Now we multiply with 2, 2, 4, 6, minus 2, minus 4, minus 6, 8, 10, 12. Then 1, 2, 3, minus 1, minus 2, minus 3, 4, 5, 6. Minus 1 equal to 1, 2, 3, minus 1, minus 2, minus 3, then it's 1, 2, 3, then it's minus 1, minus 5, minus 6. Now, this is 2, this is 5, then this is again 7, then if you calculate this, this will be your minus 1, this will be your minus 8, this will be minus 7, this will be plus 7, then this will be 17, this will be 13 here, then 6 minus 5, this is plus 1, and this is minus 6. If you compare this data yn and this yn, this is equal. Agreed? If you have any doubt, you can ask. Any doubt?
Yes.
So last class we have, so this is the odd number of samples. Somebody asked me to give this example, that's why I have given this example. So I have no doubt so far in overlap and add method, and you should be in a position to solve any such problem, okay, like that.
Sir,
You
but
can
স্যার এটা অড নাম্বার অফ স্যাম্পলস আছে, কিন্তু মানে যদি এইচএনটা যদি 2 থাকতো তাহলে কি করে নিতাম লেন্থটা?
লেন্থটা কি করতে হবে?
জিরো প্যাডিং,
একটা জিরো প্যাড করতে হতো লাস্টে।
আচ্ছা,
তবে জেনারেলি আমি ইউনিভার্সিটি যত প্রবলেম দেখেছি সবাতেই দেখেছি আমি, যদি এটা অড থাকে ওটা অড থাকে, ওটা ইভেন থাকলে এটা অড ইভেন থাকে। Generally what I have seen the different type of question paper, but if you ask me what is the procedural solution, then you have to add 1 0, then you have to make this solution
লাস্ট ইয়ার।
Another important thing, suppose n2 and n3 I have taken same length, it is not necessary, I have said that you can take n2 and n3 different. I mean block size and hn that could be taken different. Okay, suppose if you say I don't want to pad 0, then suppose if I take 3 sample here and 2 sample over there, then also it is not a problem. Around n2 and n3 could be different, that I have also mentioned in the last class. Suppose you want to make block size and hn equal, that you can do, but suppose you are having even number of sample in the xn and odd number of sample in the hn. In such a case, you don't want to pad 0, you want to follow the same procedure what we have done so far. Then what you have to do, you take odd number of sample in the block, like suppose say if xn is having 0 to 7 8 and hn having 2 1 minus 2 1 2 1 minus 1, then if I take xn equal to x1 of n, x2 of n, x3 of n, x4 of n, suppose this 6 is not there, 6 is not, up to 5 it is there, suppose say, right? Suppose say up to 5 is there, 6 is not there, then how many sample here? 8. Okay. This is 3. Now you break this 4 section. One is 1 2 3 minus 1, another section, minus 2 minus 3, then 4 5 another section. Then each block length will be 2. Small block will be 2 length and hn having 3 length. But if the lengths are different, you can still find the linear convolution. You can still find the linear convolution. Agreed?
Yes.
So then not a problem. So instead of pending 0, you can go ahead with the same procedure what we have done. You take 2 sample over there, you take 3 sample over there. In HN not an issue, because N2 is the length of each block. Sorry, N3 is the length of each block. N2 is the length of HN. Okay. Now N2 and N3 I have taken equal. It is not necessary. You can take it different. So if you have odd number of sample in HN and even number of sample in XN, then you divide the block in even number and HN will remain odd number, not an issue. Because N2 and N3 is not necessary that they are to be taken equal. Agreed?
Yes.
Now you can have opposite scenario. Opposite scenario means what? Suppose you are having odd number of sample in XN, suppose say 9 sample, and you are having even number of sample in HN. Suppose 2 and 1 is there, minus 1 is not there. Suppose minus 1 is not there. Then what happened? You are having 9 sample in XN and you are having 2 sample in HN in that scenario, right? Suppose XN will remain as it is and HN you are having 2 1, this minus 1 is not there. Then what happened? Then you divide XN block in 3 blocks, X1, X2 and X3 with 3 samples and HN having even number of samples. Then you can find the convolution. Not an issue because it's a linear convolution. In linear convolution, 2 signals need not be equal to same length. They could have different length. Agreed?
Yes.
So therefore, this is
Yes,
not
sir.
a problem. So I hope with this understanding, you should be in a position to solve any problem. If you have
Yes,
any
sir.
doubt, then I want to discuss. Otherwise, I want to proceed to next type of solution. Shall I proceed?
Yes, sir.
Very
Yes, sir.
Yes, sir.
good. Okay. Acha, what about your assignment in Z transform? Have you completed Z transform?
আমি দিয়ে দিয়েছিলাম আমি দিয়ে দিয়েছিলাম
তুমি কি অনুষ্কা?
মেল করেছিলাম
অনুষ্কা
হ্যাঁ
ব্যানার্জি? হ্যাঁ 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 পেয়েছি তোমারটা। অনুষ্কা, বাকিটা ঠিক আছে না, এখনো সাবমিট করতে আমি বলিনি, তোমাদের হয়ে গেলে আমাকে জানাবে, তাহলে আমি বলবো সাবমিট করতে। বাকি এখন লেখা হয়েছে বাকিদের?
ঠিক আছে না স্যার চলছে
চলছে। কেয়া পাল কি বলছো? কেয়া? Okay, Kea is not there probably. So, anyway,
স্যার আমি সবকটা পারিনি করতে,
কোনটা করে সবগুলো তো করে দিয়েছিলাম।
একটা জায়গাটা প্রবলেম হচ্ছে না ঠিক করে।
হচ্ছে না, কোনগুলো বলো তো, কোন প্রবলেমটা? ঠিক আছে, ওটা আমি পরের দিন বলবো না, সেগুলো আলোচনা করবো, ঠিক আছে? ওকে,
ওকে স্যার
next is overlap and same method. Overlap and same method. Now, in overlap and same method, I have written steps instead of theory. Now, suppose we are here also a same thing. Same thing means you will be having one longer sequence and one smaller sequence. Now, suppose step 1, you have to determine the length of the impulse response Hn, and you have to determine m-1. Just in the previous procedure, same thing. Here I am written the length m. The first step will be to determine the length of Hn. That will be m and denote by m-1. Now, from the given input signal xn, you have to assume the length n. See, what we have done in the previous overlap add method, the choice of block data is yours, because impulse response length that is given, because impulse response is given means that length is fixed, it is predefined. Now your xn is given, from that you are identifying the blocks. Now that block length is up to you. You can take odd, you can take even. Now in this case also, first hn is given, from that you identify the value of m. Once you identify the value of m, then from the given data xn, you have to take the block length. Now suppose say each section having length L, each section having length L, that block length you can find using this equation. Now suppose once you assume the input sequence, given input sequence, we will assume some n, in the sense, suppose if you are having 10-point data or 12-point data, I will assume some length of the block first. Let us say I will assume 4, 5, 6, something like that, 4. Now from this we will assume, we will find the length of the block using this equation. Now what you have to do, you have to pad L minus 1 zeros to Hn. Now L minus 1 zeros to Hn, that means some Hn will be given, in that you have to add L minus 1 zeros. Okay. Now step 5. In step 5 what you have to do, now total sequence xn you have divided into, say, 4 number of blocks. This block length is L, each block of xn. Now from this entire xn I have divided into L number of blocks. Now in this L number of blocks, this data I am denoting by x1 of n. This data we are denoting by x2 of n. This data you are denoting by x3 of n. And this data you are denoting by x4 of n. Now what you have to do, then you have to add m minus 1 number of zeros before that. Now what is m? M will be the length of hn. M will be the length of hn. Now what I am saying, that if this is x1 of n, we are padding m minus 1 zeros. Now next x2 of m, you have to pad m minus 1 data points from x1 of n. And x3 of n, you have to include m minus 1 data from x2 of n. Like that, for x4 of n, you have to add m minus 1 previous data. So for each block, you have to add m minus 1 previous data. Right? Hello, are you hearing?
Yes, sir.
Yes.
See, so what is the difference between this previous method and this method? Anyway, this will be more clear when I will discuss example. First you have to, I am explaining the procedure. In this method, we will compute using circular convolution. So circular convolution, and previous problem we have computed each section using linear convolution. Right. Now circular convolution we have to compute for each section. Right. Now the difference between previous method and this method, in previous method we have not padded or zeros, but in this method we have to insert zeros earlier. Right. Before, after introducing 0, we have to make this computation.
Hmm.
Now, what I am explaining in this step 5, that you have to add m-1 number of sample from the previous data, right? M is the length of the impulse response. Now total number of data is xn, and this data is divided into, suppose say 4 sections. Well, xn is divided into 4 section means this section is x1 open, this section is x2 open, this section is x3 open, this section is x4 open, and total length, this one is the x open. Now x1 open, x2 open, I am adding the m-1 sample from x1 open. x3 open, I am adding m-1 sample from x2 open. And x4 open, I am adding m-1 sample from x3 open. Now for x1 open, before that there is no data. That's why we have to add m-1 number of zeros in this. Agreed? Okay. Now, after doing this, what I have to find? I have to find the convolution of x1 open with hn. And in hn, I have added l-1 number of zeros. l-1 number of zeros. Okay. Now, this is hn. So new hn with l-1 number of zeros. I have to find the convolution of this entire block, circular convolution of this entire block with this block. Now this entire block, I have to find the convolution of this block. This entire block, I have to find the convolution of this block, circular convolution. This entire block, I have to find the circular convolution of this block. Okay. Now, once you find the circular convolution of each block, then we have to add all this section. Now, after convolution, what you will be having? You will be having 4 sections: y1 open, y2 open, y3 open, and y4 open. Now, from this different section, after these are the y1 open, this is the circular convolution of x1 open with m-1 of 0 with hn, and y2 open, that will be circular convolution of x2 open with additional points of x1 open, and this is y3n is the another circular convolution x3 open in hn, and this is x4 open hn. Now the result will be, we have to discard or we have to eliminate this portion. So discard this portion. This is also first m-1 portion, next first 1 m- portion, next set of data also first m-1 portion, then output will be y1, y2, y3, y4. You take it as it is. This will be the total output. All right. So tomorrow we will discuss one example of this, then it will be very clear to you. Okay. So
Sir.
বলো বলো।
বলছি আমি না মাঝে কেটে গেছিল, একটু প্রথমে স্টেপ গুলো বলবেন, ফার্স্ট 1 2 3 গুলো।
1 2 3 গুলো
একটু বলুন।
হ্যাঁ,
হ্যাঁ,
প্রথমে স্টেপটা হচ্ছে যে তোমার কি দেওয়া থাকবে, একটা ইম্পালস রেসপন্স দেওয়া থাকবে আর একটা এক্সন দেওয়া থাকবে।
হ্যাঁ,
তাহলে প্রথমে ইউ হ্যাভ টু ফাইন্ড দ্য লেন্থ অফ দ্য ইম্পালস রেসপন্স। তাহলে লেন্থ অফ দ্য ইম্পালস রেসপন্সটা আমি এম পেলাম, বার করতে পারবো, দেওয়া থাকলে গুণে বার করতে পারবো। তাহলে ইফ আই ক্যালকুলেট এম, দেন আই ক্যান ক্যালকুলেট m-1, so not an issue. Very good. Now I have given, suppose say, a signal of xn. তো সেই সিগন্যালটাকে ধরো 12টা পয়েন্ট আছে, 12 points are there. Now I have to make a decision যে how do I divide the block. Let us I make the decision that I will be taking 4 data in the block, in a block. So I will make this decision. Okay. Now, if I make this decision 4, then I will assume n equal to 4. And from this, my n is now known. M minus 1 is also known. Then I can find the value of L. Okay. Now I have to find that L minus 1. Whatever be the L minus 1, suppose L equal to say 4. So 4 minus 1 means 3. So now I will pad 3 number of zeros. Now 3 zeros will be padded with HN. This is the procedure.
জিরো গুলো কেন? ও আচ্ছা, প্রসিডিউর।
This is the procedure. মানে how this procedure is explained. এই জিরো গুলো কেন হচ্ছে? Let me answer. In this problem, we have to each section we have to perform circular convolution. To perform circular convolution, what we require? We require length of the signal should be same. Right? So length of the signal we have to make equal. So in order to make it equal, we will pad zeros. Okay. So this is the steps in the procedure. This is how it is explained. Okay. Now when you take an example, it will be more clear. Now, once we have, suppose say xn is the total sequence, and I have x1, x2, x3, x4, 4 blocks. Now, in x1 of n, x2 of n, x3 of n, x4 of n, I have taken it out. Now, in x2 of n, I have to pad first m minus 1 data at the beginning. Similarly, each section I have to pad m minus 1 data from the previous section. Okay. Previous section we have to take m minus 1 number of data, and m we have calculated already. Now, in this first block, there is no previous section. Since there is no previous section, I have to add m minus 1 number of 0.
Yes, sir.
Right? Now,
Yes.
this will be my total x1 of n, this is my x2 of n, this is my x3 of n, this is my x4 of n. Now, for each section, I have to find the circular convolution by convolving with Hn. Circular convolution. Once you find the circular convolution, then I will be having y1, y2, y3, yn. In this y1n block, I have to discard first m minus 1 data. Then again first m minus 1 data I have to discard. Then again I have to discard from next block first m minus 1 data. From next block again I have to discard first m minus 1 data. So whatever I will have, remaining part, this part, this part, this part, and this part, this will add, and this will give you the final output. Agreed?
Yes, sir.
This is the procedure for overlap and same method. Now we will take this example. This example I think I will take next class. Okay, next class we will discuss this example in detail. Now I have 2 minutes left anyway. Suppose say this is the example. Xn equal to this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data in Xn. This is 3. So what is Hn? Hn equal to 1, 2, 3. M equal to 3. M is the length of Hn, right? So m minus 1 kotha hobe 2 bar korlam
2.
Now this is the length, right? So I have taken n equal to suppose say 4. So I will take 4 data. I have to assume n equal to 4. Let. So if n equal to 4, then what is the L of L? L equal to 2. L equal to 2. Now my block length I will choose. Block length. Block length I will choose 2. So next part of the solution we will discuss tomorrow. So next I will take 2 data from here. This is 2 data. Then 2 data from here, 2 data from here. How many sections will be there? How many sections? 1, 2, 3, 4, 5. You know, 6 sections I will be there. Now I have to pad how many zeros over there? 2 zeros in the beginning and 2 data from each section. So total data will length will be how much? X1 এর length হলো কত বলো তো? 4
মানে
+2 হবে কারণ এখানে দুটো করে আমি পেলাম, এখানে দুটো, এখানে দুটো, এখানে দুটো করে আমি পেলাম তো, তাহলে এখানে দুটো করে আর দুটো করে আমি দুটো m - 1 0, তাহলে প্রথমটা আমার 4 হয়ে যাবে, তারপরটা 4 হয়ে যাবে, তার প্রত্যেকটা কত হয়ে যাবে? 4 হয়ে যাবে, 4 হয়ে যাবে। আর এই চেনটা কত আছে? 1 2 3। এটা যদি l - 1 0 করি তাহলে কত হবে? 4 হয়ে যাবে। হ্যাঁ, l - 1 0 অ্যাড করে দিতে 4 হয়ে যাবে। তাহলে আমার এটা কনভলিউশনটা করতে পারবো। ঠিক আছে? সো আই উইল ডিসকাস সলিউশন নেক্সট ক্লাস। ওকে, আর 1 মিনিটের কম সময় अवेलेबल আছে। ওকে,
Okay,
tomorrow
thank you,
we'll
sir.
okay fine, tomorrow we'll discuss the solution of next week.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thanks.